going on, everybody? Happy Tuesday. Is it Tuesday? I don't know what day it is anymore. We're just live. We're live. It's Tuesday, folks. Happy Tuesday. Hope everyone's doing well. How's everyone doing? Whew. Look at everybody in here. What's up, everyone? How you doing? How you feeling? We're gonna do it live. Monday class threw me off for sure. Yeah. I was like, wait, no. Class? Yep. I liked it though. Yesterday was so much fun for me. I really enjoyed Monday's class. Excited for class. How you doing? I'm doing all right. Doing all right. It's been a grind, folks. It's been a grind this week. Anonymous Cheer, thank you for the 100 bits. I appreciate you. Thank you for being here. Are we hearing double? There is. Oh, the break music was still playing. Sorry, my DJ skills just weren't there. I couldn't mix them in real time. I did take a DJ class for what should have been a longer period of time. Did you get a cat? No, unfortunately, I don't have a cat. If I ever do get a cat, I love cats. Cats have utility. Cats will go after mice. They'll get the creepy crawlers. So I'm a big cat fan. Karma with the 5 months. Hey, thank you for being here. Thank you for the 5 months of Andy's Bucks. Yeah, I think I'm gonna stick with Andy Bucks for now on. I appreciate it. Yeah, I've always wanted a cat. I want a black cat named Salem. I think that's kind of my jam. I was always really into Archie comics. I have like an absurdly large collection of Archie comics, like more than any reasonable person should. And I think Betty and Veronica led to my Bachelor fascination. Mansa said, I got a job interview thanks to networking. That sheet works. Yeah, let's go. Thank you for the 4 months of Prime. I appreciate you. Thank you so much. Let's go. That's what I need. That's the energy I need y'all to bring. That's the energy I need right now. Let's go. What? Crumb Hustler, thank you so much for the 5 gifted subs. I appreciate you so much. Thank you for the support. Turn up. Let's go. Hype train out the gate. People getting interviews. I don't know if y'all checked the Celebration channel recently. But we need a wall of emotes. Let's get like a wall of either Micro Leon or Bob. For Mitch. Go for Mitch. Wow. I don't know if y'all saw that in the Celebration channel yet. I'm gonna read it. I just received a signed contract from my technically 5th client. Get out of here. They're a repeat client for another site. I sold the site for upwards of $4,500. $4,500. Hold on. $4,500. What? Couldn't have made it possible without this community. That's facts. Facts all day long. Let's go. Y'all, I like when y'all save the really good stuff right before I go live. It gives me the energy, you know, it gets me going. It's provocative. Hey, that is wild. Congratulations. That's a huge accomplishment. Very, very, very proud. That's awesome. Way to go. What? Chop, thank you so much for the 5 gifted subs. I appreciate that. Thank you so much. Hopefully folks getting those emotes back. I love it. Appreciate it. Ooh, I never saw that before. That's a cool thing on the hype train. Hadoken with the 5 months. Hey, I appreciate you. Thank you for being here. Mom with the hydrate. How you doing? How you been? Cheers to you. Sorry, folks. I got the devil's elixir this evening. The devil's elixir is in play. I got my water. Got my water teared up. but I also got the devil's elixir. Anybody remember what the devil elixir is for me? I've mentioned it once before on stream. I don't know if anybody remembers what the devil elixir is. It's not alcoholic. It's not alcoholic. Yeah. Count the shells remembered. Count the shells remembered. This is the cotton candy rockstar death juice. The devil's elixir. It gets me going though. That's all I gotta say. Every once in a while I need it. Every once in a while I need it. Today is one of those days. So Cat's just Cat. I just know I'm pissing Cat off. Like I see them getting angry. No comment. Whew, but boy, is it tasty. Alrighty, folks. We got a lot of good stuff tonight. Tonight we're hitting up the last of the 2 of the 4 pillars of object-oriented programming. I'm going to chill the music here. That means we're hitting up our inheritance and we're going into polymorphism. Okay, 2 topics that are at surface level. I think inheritance is a little bit easier to pick up. Polymorphism is just like a what? Like what are you talking about? Like what did I just read? Why does nobody ever just like explain what the hell it is and like why it's useful? So hopefully tonight, by the end of tonight, you'll feel comfortable. You're going to feel comfortable with encapsulation. You're going to feel comfortable with abstraction. You're going to feel comfortable with inheritance, and you're going to feel comfortable with polymorphism, at least like at a surface level. At least you understand why and where it might be. And we're going to leave the nerds to shake violently over the nitpicks, and we'll save those for a later day. So hopefully we can get through all big of those big 4. And then at the end, I want us to get on Remo. And on Remo, we're going to get into groups, and you're going to teach back the things that we learn and talk through this evening. So you're going to teach back what is encapsulation, what is abstraction, what is inheritance, what is polymorphism in a small group, right? And I'm gonna keep kind of shuffling the groups of folks so you can talk about it with different folks, hear it come from different perspectives, hear it be explained in a different way. And so we're going to have some fun on Remo after class to just kind of get the juices flowing. These pillars of object-oriented programming really don't make sense, right? They just don't make sense until you've like gotten the muck with it. And so that's what we're going to do. We also want to finish up the tic-tac-toe. So lots of fun stuff to get into tonight. We got to get through some really big, heavy topics. We're going to get some like one-on-one FaceTime on Remo as well. And we're gonna tease just a little bit about Thursday. Thursday is the whole shebang. Thursday we got it all cooking, folks. Thursday, prepare yourself. Prepare yourself for Thursday. Not only do we have the things that you know about, not only do we have VIP getting released, not only are we doing the Pokemon drawing, but we're talking about the future of 100 devs. Things that are going to take this to the next level. Things I've been cooking up for a long time. And I just closed another deal today, folks. Just closed another deal today. Just closed another one. Just closed a whole another deal today. So I'm gonna tease that on Thursday as well. I am super excited. This is stuff I've been working on for months. And I'm just really excited to have it come to fruition. I'm excited to share it with y'all. And it's going to be a wild, wild week. So we got OOP done this week. We got some really exciting news on Thursday. We got all the big things that we've been waiting for. Let's get it. Let's get into it, folks. Lewis, welcome. Glad you found us. All right. Thank you, everyone, for the subs and the bits and the support. If you're new, that all goes directly to the nonprofit I work at during the day, Resilient Coders. So I appreciate it. Thank you, everyone. Alrighty. Let's get into it. Some things to talk about, some things to review. And then we're going to jump right into OOP. We're going to review the encapsulation. We're going to review the abstraction. We're going to walk through those slides again, get our spaced repetition in, talk through it. We'll be good. All right. Questions? Any questions before we jump into it? I always like to leave a little bit of space for some questions in the chat. Have you checked your Discord messages for today? Hell, sorry. One of those days. One of those days. One of those days. Let me tell you. One of those days. And so I am committed to getting through them. I've been chipping away at them here and there, trying to go with the folks that were like furthest down the queue first. So after class tonight, I'm blocking off another block of time to get through them. I will hopefully catch up today. If not, you'll see me kind of plugging away at them tomorrow as well. Are you saving the VODs? Yes, they all go on YouTube. So all the VODs will eventually make their way onto YouTube. All the class ones are up there. I've already downloaded all of the office hour ones and the special class ones. It's just putting them up in, I don't know if I should put them, would you like them all in the same playlist or a different playlist? Like, would you want everything in just that one software engineering bootcamp playlist? Or would you want like a separate playlist for like the career skills, a separate playlist for different playlists like office hours? Yeah, organized, different playlists. All right, we'll do that then. I think that makes sense. Should we anticipate using Remo for most classes going forward? Probably once a week we'll be on Remo. Always feel free to not have your camera on. You can have voice on as well, so you can just have voice. Some folks kind of don't want to be on camera. I totally get that. Voice is fine, okay. Cool. All right. Didn't miss anything, Cookie. We're just getting started. All right. Alrighty. Networking. We're picking it back up again next week, folks. Next week, the networking comes back. I want my connections. I want them. I want my connections. So next week, you're picking it back up. The networking comes back into play. We'll ease into it. We're just going to have, like one connection due next week just to get back into the fray. But remember, the skills aren't enough, folks. I have to repeat it multiple times. The skills aren't enough. And so we will be bringing back the networking. We gotta get back into that groove, right? We gotta get back into that groove, or else it's gonna be hard comings when we're trying to get a job. So networking comes back next week. The skills would be nice though. They would be. They're a part of it, but they're a part of it, right? It's a piece. Client deadline. I'm going to give you an extra week. And today was supposed to be the deadline. All right. It's supposed to be today. Going to give you an extra week. Remember, if you weren't able to secure a client, that's okay. You have some alternatives. You can volunteer for a grassroots organization, or you can contribute to an open source project. Highly recommend checking out this first timers only, right? Click on that link, find an issue, start committing code to it. Totally forgot about the deadline. It's been on every slide ever. Got a client. I'm just waiting for them to sign. That's awesome, Rudy. That's awesome. My client is yet to send me the signed contract. Story of my life. Sometimes people drag their feet. That's what happens. How do we submit the homework in the Code Wars? After class, I'll open up not only the homework for submitting this week, but the homework that'll be due next Tuesday as well. I'm just going to ask for the link to your repo. So you're just going to give me the link to the repo for this week. This week was just like your Code Wars, and that's it. So I'm just going to look for the link to your repo, and we'll call it even on that one. All right. Any booking times available? Not right now. I haven't opened it. I think when we get over to Remo, I'll open them. I just need a moment to set it all up. Hey. What? Oh, it's a 3-month gift sub. Thank you so much. What? Who actually? How does that show up? Is that Arabog? Okay, Arabog. Thank you for the 3 months. That's wild. Thank you so much. Rezo with the hydration. Cheers to you. I'm still finding out about a lot of these like interesting ones. Yeah. They pop up and sometimes they're weird and I haven't seen them before. Cheers to you, Rezo. Thank you for the hydration. Alrighty. Like I said, I'm a little behind on the mod mail. I'll get through that today after class. But let's keep going, folks. Let's keep going. We have your crafting our story class on Friday. So this Friday, we'll have another class on crafting your story. We'll do another couple live sessions. We'll get some more varied folks. And we'll also be releasing the professional checklist. The things that you'll need, right? The things that you'll need to kind of have done as you move into applying for jobs. So we're going to put that whole checklist together so that you have it, so that as we start kind of getting into the full stack development, we're also going to be getting into like building out everything that we need to really start applying, right? That's what we're looking for. Office hours will be this Sunday at 1 p.m. Eastern time, just as a reminder. Cash, we don't have a date yet. As soon as I have a date, I'll let you know. All right. Chat, what's an object? Let's get into it. Let's jump right into it. What's an object? It's an object, chat. Ooh, a collection of keyed elements. Key value pairs. Everything. Everything. Key collections. Love it, love it, love it. Grandma's car. All right. We're going to dive into the objects very quickly. Remember, we're going to use, understand, and then build. And we're going to make some nerds angry tonight. Just like we made them angry last class, we're going to make them angry tonight again. We're not going to use a lot of the technical terms. We're going to try and stay away from them because they don't make sense. They're big words. I'm going to treat them as disrespect. And so we're going to stay away from them. Tonight for the inheritance and the polymorphism, I use some of the big words, but we're going to really deconstruct and break them down because they're just really wild topics, and we're gonna get to them, but we're not going to go deep on these things. When it comes to things like polymorphism, there's like 3 different kinds. There's all these different variations. We're not here to nitpick. We're here to learn, and so. We're going to make some nerds angry tonight. They're going to be shaken violently when we go over these topics, but the goal is to walk away having an idea of like what and why. Like, all right, what is it, but why is it important? Why do I want to use it? Why do I want to add it to my code? Right? That's what we're trying to go for today. All right. Chat got it right. Objects are a collection of variables and functions that we use to represent the attributes and behaviors of something in a program. We call the variables that are tied to the object properties, and we call the functions that are tied to the object methods. And yeah, it is a keyed collection. You can use the key to get the value out of the object. All right. I always like to think of a physical object, right? I like to think of my stopwatch. Chat, what's a property that this stopwatch has? Give me a property. Give me a property of this stopwatch. Yeah, it has a color property of black. What's another property here? What's another property of this stopwatch? Yeah, it has a shape of round, right? Shape of round. And it has a minutes of 3, a seconds of 59. All of these are properties that make up this object. What are some methods of this object? What are some methods? Yeah, it has a start method, a stop method, a split, a reset. Nice. All right. Chat, what kind of notation is this? I'm creating an object here. What kind of notation is this? Yeah, it's literal notation. I'll take it. Yeah, I like that. Literal notation. We're literally creating objects. We're literally adding properties. We're literally adding methods, right? And so here we are creating an object that has properties and methods. Nice. Chat, if we wanted to create a bunch of objects, what could we use? We want to create a bunch of objects, what could we use? Nice. A factory, a constructor, and then ultimately when we get to the newer syntax of JavaScript, what are we using? Nice. A class with that lovely constructor in it. Cool. When we think about these factories, think about like a real factory, like a car factory. Spits out a bunch of these different cars. The cars all come out of the factory with very similar properties and behaviors, right? So it can have a certain number of doors. It can all have a color, a model, a make. And this constructor function makes it really easy to spit out objects that are similar. With the newer syntax, we got the class-based syntax that we see here, where we have the constructor and the methods all part of this one class, right? And putting all of these things together, like putting all of the like bits of data and the bits of functionality together, that's an example of what? We're using objects, we're doing something. Yeah, okay. I see y'all using the big words tonight. Using those big words tonight. I love it. Encapsulation, exactly. All right, encapsulation. When we put all of our data and functionality together, we're using that encapsulation. Nice. Disrespect. You're using big words. Do y'all know where that comes from? The 40-year-old virgin. I'll share the class. I'll share the link after class. Nerd shake. Nice. All right. So why are objects such a big thing? We know JavaScript, everything is an object, but like, why are objects a thing? Why do we need like these factories? That's weird. Why do we need any of this stuff, right? Well, what if there was a system, a paradigm, a set of rules, an agreed upon way to structure our code that would make things easier to add new stuff, make it easier to read through what was already coded, and made it so if you were not afraid to make changes, right? What if there was a way that when we were writing our code, we didn't fear adding new stuff, we didn't fear making changes, and it was way easier, right? It was way easier to see what was already coded. What type of system could we use, folks? What type of system could we use? I think I know a system. I never watched this part back. Just feel it. It'd be object-oriented programming, baby. OOP. That's what we're doing. It's a system. That's all it is. It's a system. It's a paradigm. It's a set of rules. It makes it easier for us to add new stuff. Easier to read through what's already been coded. It makes it easier for us to make changes and not be afraid of making changes. It's OOP, baby. It's object-oriented programming. That's what we're learning. All right. Let's quickly review through the code from last class. We're finally getting to the point where I dance when this song comes on. Yes, that's what I'm talking about. I just feel in my head everyone's just like they're like in their kitchen just like going wild when the song comes on. That's how I feel like I'm at like I don't know, like some sort of EDM concert. Alrighty. Here is some code that we saw last class. All right. Coachella. Yes, That's mine now. Sorry, I'm taking that. I'm using that. Coachella, mine. I'm using it. Thank you, Magic. Coachella, hold on. 10-second warning. 10-second warning. We're going to bring back the music. We're going to bring back the flash. 10-second warning. 10-second warning. All right. That's our conference. That's the name of our conference, folks. Back when the pandemic's over, when the pandemic is over, and we can like meet, and we can like have people like come together, it's Coachella. That's what we're calling it. I don't care if I get sued. We're calling it Coachella. They can come find me. Everyone cosplays as Bob. Coachella. Oh, it's so fire. Nobody steal that domain name. That's such a good name. I'm sure somebody's thought to do this before. Leon, it's midnight. My neighbors are going to scream at me. I'm sorry. Getting through OOP has to be fun. And this is one of the ways I know to make it fun. I got to dance through some of it. I'm reading that eloquent JavaScript book, and I'm like, bruh. And I just got to play the music. I just got to play the music, or else I'm just like, what the frick am I reading? All right. Cool. Here's some code that we saw before. We have an hourly rate. We have a function. We're calculating some profit here, and Coachella was registered back in 2011. Damn. All right. Is it easy to add new features and functionality? Interesting. Do you think using this kind of procedural, right? Using this kind of procedurally written code, is it easy to add new features and functionality? What do you think? Maybe, but can other developers look at my code and understand what's happening? Maybe, right? But is it clear? Is it intuitive? Can I just like look at it and know what's going on? Right? Can I just look at it and be like, all right, I know exactly what's happening here. I know everything that's what's functioning, like what's happening here. Maybe I think it's a little bit harder. And as we start to add more and more stuff, it's just going to get more and more complicated. Right? Like the idea here is that we're going to keep adding these functions. We're going to keep adding these like variables, and it's just going to get more and more complicated. When I kind of change like the hourly rate, am I messing with the hourly rate here or the hourly rate here? Is it affecting any of the stuff that's in these functions? I have no idea, no clue if the things that I am like changing or modifying, if they like are impacting something else anywhere else in my code base, right? And so when I look at code like this, it makes me worry about making changes. I lose sleep at night. I'm not sure what's happening. And so we have some easy to use concepts. They're going to fix that code spaghetti, that hot mess for us, right? That hot mess for us. Alrighty. So the things that we learned about last class were this idea of combining data and functionality, right? This idea that we had that data that was at the top, hourly rate, hours, tax rate. We had some functionality like calculating profit. And what we wanted to do was fuse that data and functionality together. And when we fused that data and functionality together, it just became a lot more readable, right? This became a lot more readable. All right, well, I'm looking at a serious business person here, and I can see that there's an hourly rate and a calculate profit, and I'm using this dot hourly rate. I know that this hourly rate is tied to this one here, and it's tied to this entire serious business person object. So this makes it a lot easier to see like what data is being affected, what functionality is tied to that data. It just brings everything together. It's nice and neat. You can go ahead and add new features, right? Like we can calculate profit. We can also add calculate taxes held. And we know that we're just kind of dealing with this one thing, this serious business person, right? So I can keep adding new features. I can keep adding new bits of functionality, and it's all tied to this one thing, right? And so another developer can look at this code as well and know kind of what's happening. All right, it's a serious business person. They have all these things that are this data about them. They have all these things that they can do. And I can make changes like to the tax rate here and know that this method's not going to like bork, right? Like it's not going to break something somewhere else. All this data and all this functionality is tied together. So when I make simple changes, I know that I'm not messing something up, and I'm not messing something up way down in my code base, right? How do you incorporate DOM manipulation OOP? We'll get to it. Also, the DOM is like a beautiful example of like OOP in practice. Dragonoid, thank you for the hydration. Cheers to you. Cheers to you. The devil's elixir. I love it. Alrighty. Digital Fendi with the stretch. Oh boy. Hold on. BRB, folks. That kind of stream. Oh yeah. You want this kind of action? You know what you got to do. It's only 1 million channel points, folks. Play money. Not that kind of stream. The devil's elixir is Rockstar cotton candy. That's what it is. Yeah, and this is like 99% of like my dishes is just stuff that I'm reusing. I don't throw out like pasta jars. If I ever get takeout, I don't throw these things out. I love this. This is what a cup should be. This is what a cup should be. It's big, holds lots of stuff. People just throw it away. They just throw it away. Alrighty. So now, since I have put my data and functionality together, I have fused these things together. I have, dare I say, hold on, warning. Dare I say, encapsulated my data and functionality into one object. It just makes it a lot easier to do the things I want to do. Am I right? Using our data and our functionality together, right? That's encapsulation. That's all it is. All right. The process of storing functions or our methods and their associated properties in one thing, an object. That's encapsulation. Let me get out the way here. Nerds are going to start shaking violently. But Leon, what about this one thing that we hadn't thought about? No. Just a good general idea of what encapsulation is. We're going to use that to carry us into writing cleaner, more maintainable code. All right. Is it easy to add new features and functionality? Let's talk about the Gaja Classic Pro. The Gaja Classic Pro. All right. Heats water. This espresso machine heats water not only to put water through your espresso beans and to brew excellent coffee. It also brews water to send water out that steam wand so that you can froth your milk. Exactly, Wolfpack. It is the best prosumer model in the market now with a new foamer. All right. So this coffee machine, I just misspoke. This espresso machine does a lot of stuff, right? And it does a lot of stuff without us really needing to understand what's happening underneath the hood. I press a button and I just know that it's going to start heating up the water and eventually brew or make a nice pour, right, of my espresso. I know I can press the other button and steam will come out the wand. I don't need to know what's happening behind those buttons. I don't need to know what's happening for that water to be poured or that steam to come out. I also like to think about this in terms of like a car. I can sit down in pretty much any car and drive it. If it's a Tesla, I don't need to know that it's all electric. If it's a Subaru, I don't need to know that it's all gas. If I'm in a Prius Prime, I don't need to know that it's both. I don't need to understand how the engine works. I don't need to understand how the brakes work. I just have a very simple interface, which is my steering wheel and like 2 pedals, right? So I have an interface that's a steering wheel and 2 pedals, and I can drive pretty much any car. This espresso machine is the same thing. I don't need to know all the stuff that's happening behind the scenes. I press one button, I get espresso. I press another button, I get steam for the wand. Right? That's it. Now, the unfortunate thing about this espresso machine is that the steam wand sucks. It's bad. It doesn't give you the frothy milk that you deserve, right? All right? It doesn't give you the frothy milk that you deserve. It sucks. And so what engineers should probably start off by doing is not throwing out everything, but maybe just paying attention to the wand. Like, would 1 hole versus the crappy 2 holes that they provide on it, would that be better? Like, they don't have to rebuild the entire espresso machine. They can just start by focusing on the wand, right? And if you just focus in on the wand, that enables you as an engineer to add features and functionality, but without worrying about everything else that's happening in the background. If you had to always constantly worry about everything in the background, you would never feel comfortable or safe adding new features or functionality. So when the engineers working on this espresso machine have to fix the crappy wand that it comes with, they don't really worry about the water boiler or the circuitry or anything else except for that, like the metal of the wand, right? So you can say things like the water boiling or the circuitry, that's all been abstracted, right? It's been abstracted away. You don't have to worry about it, right? Let's look at some code. Let's look at some code. This code was a lot. We spent a lot of time going through this. The problem here was that my users could figure out my hourly rate, right? When I create an agency contractor from this constructor function, it's very easy to pull out my hourly rate, and it's very easy to pull out my profit, right? What I did here, though, is I have abstracted out those values. Here, you can no longer see my hourly rate just when you ask for it, and you can no longer just get the calculate profit. This is really helpful, right? This is really helpful because my clients can still get their invoices, but not see my hourly rate. I don't want them to see my hourly rate. And don't worry, we're going to see another really good example of this later on tonight. So tonight we're going to have like a way better example of this. So I still want my clients to be able to see their invoices, but I don't want them to be able to see my hourly rate. And when I am working as an engineer on my espresso machine, I don't have to worry about like other things than except for the one thing that I want to work on, the one feature I want to change, the one thing I want to fix, right? So water boiling was hidden from the steam wand. Hourly rate was hidden from the client. I'm only exposing the things that make sense. I'm only showing you the things that will impact you right now. And so all the complex or unnecessary details are hidden. And this enables you to implement things without kind of understanding or even thinking about all the hidden complexity. You are able to sit down in that car and just drive. The engine is abstracted away from you. You're able to sit down in that car and drive. The braking mechanism is abstracted away from you. You're able to sit down in that car and drive, right? And the how the headlights come on and illuminate the pathway has been abstracted away, right? So when we start thinking about objects in real life, this becomes a really easy concept to understand, but we want to apply that same ingenuity to our code, hiding away the complexity, only exposing the things that need to be exposed. And we're going to get some practice with this later tonight and like see why that's important for like maintainability of our code. But the big thing is that it enables us to have smaller, more manageable pieces of code. Smaller, more manageable pieces of code, and enables us to do stuff just once. We don't have to constantly reinvent water boiling. We don't have to constantly reinvent like how the engine works, right? We can put that engine in every single car and it's the same thing, right? So hiding out the complexity, breaking our code down to smaller, more manageable pieces of code, doing stuff once. This all sounds an awful lot like abstraction, baby. That's abstraction. It's abstraction. That's what it is. That's what it is, baby. Swear to get it. Hey. It is. All right. Abstraction enables us to hide the details and just show the essentials. This is really important. If we are engineers working on code, we don't want to constantly be tripping over something else that isn't what we're trying to focus on in the moment. When we're fixing the steam wand, we don't want to have to worry about how the water is being boiled. If we need to fix like the steering wheel, we don't want to be worrying about the engine. If we need to fix the brake pedal, we don't want to have to be worrying about like the engine. We want to be able to focus on individual pieces at one time and feel really confident, right? Feel confident that the things that we change won't actually like affect anything else, right? So if we're confident that we can not stumble over other pieces of our code, we can abstract out the things that we're worried about or the things that we're working on, right? That enables us to write more manageable code. It also enables us to like sleep better at night. We know that the thing that we're working on isn't breaking everything else somewhere else down the line. Alrighty. Ooh, encapsulation binds and abstraction hides. I like that. That's pretty dope. Alrighty. I'm at work right now and that music came on. No. Doing stuff once is having good abstraction. Yes. Yes. All right. Let's start a farm, y'all. Gonna live my vegan dream. Let's start a farm. Alrighty, here we go. Here is an animal class. And this animal class is a pretty standard class. It's a pretty standard class. We have a lovely class keyword, capital letter animal, letting us know that it is a class. Remember, it doesn't really do any extra. It's just letting us know that it's a class name. The constructor takes in one parameter where we can pass in a name. And so every animal, right, every object that comes out of this class will have a name. And every animal that comes out of this class will have the ability to make a sound, right? So no matter what we do, right, no matter what we do, every animal we create will have a name and the ability to speak. All right. Chat, what do we want? What if we want a bunch of different animals on the farm? What are we going to do? If we want a bunch of different animals on the farm, what do we want to do? Well, yeah, you're right. A factory, a constructor, right? What if we want a bunch of different animals on the farm? Well, we could just start spinning them out of this animal class, right? We could keep just using this animal class, but eventually, if we're building on a farm and we want to keep track of a bunch of different kinds of animals, we know eventually we're going to have dogs, cats, sheep, cows, every type of thing. Each of those different animals might have different things, right? Like the kind of like some animals might have a breed. Some animals might have like a place where they live, like a certain part of our farm where they have to stay. They might all have different ways that they speak, right? So we could kind of just use that animal class, or we could extend animal for each type of animal that we are going to create. And that's what I've chosen to do here. Here, what I've done is I've taken this base animal class and I'm going to extend it for each animal that I want on my farm. Okay, let's take a look at this syntax. So here, we'll look at the base animal class first. We've all seen classes before. You've all built them before. Let's start seeing some extra stuff we can do with them. Shouldn't be fear. Shouldn't be anything. We're just going to use the same things that we've done. We're going to introduce a few new things as we kind of go along. All right. So here we have animal class with constructor that every animal is going to have a name. Every animal is going to have the ability to speak. We can then go ahead and extend animal to create a dog class. And then we could use that dog class to create any number of dogs that we would like. So here's something neat. This super, whenever you see super, what that is enabling you to do is to go up to the parent class. So what we have here is we have animal, which we would call a parent class. And we have dog, which we would call a child class. You might also hear something called subclass or other things like that. Nerds shaking violently, am I right? But for now, let's just think of a parent and a child. And we know that dog is a child of animal because it's extending it. That's the key word there, the extending, right? So now we have the cool thing of super means that we get all the stuff that came with animal, right? Like the name ability, like the setting of the name. We get all of that from the parent. But we can also add things that we care about on dogs, like a breed, right? All right. A breed. Oh, I love that in different goes. I mean, JavaScript really doesn't have classes anyway. Why get pandactic? I can never say that word. You know what I'm saying? All right. So this is really neat because now I can start creating new dogs, right? I can start just creating more and more new dogs. So I'm going to go ahead and copy this real quick just so that we can see it. And I have just a nice little Coachella open here. And I'm just going to refresh to make sure there's nothing in here. I'm going to paste in this code and I'm going to hit enter. If I ask for Simba back, it's a little bit bigger. If I ask for Simba back, sorry, there we go. If I ask for Simba back, you can see that Simba has a name and a breed, all right? Has a name and a breed, and we can ask for that. We can say, all right, Simba.name. There we go. he definitely doesn't care that I'm using his name right now. He's just sitting there, just like chilling. And then I can do Simba.breed and get shepherd back. So I was able to create a dog, right, from this new dog class, but I got all the goodies from the animal class by using this lovely super, right? All right. You can also see that there's this proto element of animal. So we can even see in what Chrome is showing us that the dog actually is a child of animal, which is pretty cool. Can you extend without using super? Yes, you can. But super gives you the some reusability here. You don't have to like reinvent the wheel. You can take all the good stuff from animal that you want and then just add the slight differences that you want on your child class. It does take in the parameter. Yeah, cool. All right, let's go back to the slides here real quick. All right, here's from the MDN. I really like what the MDN said here. So I put it in here and there's a great link to the MDN here. And I just want to read through this so we can talk about it. If you find yourself starting to create a number of objects that have similar features, then creating a generic object type to contain all the shared functionality and inheriting those features in a more specialized object types can be convenient and useful. All right, let's break this down a little bit. If you find yourself creating a number of objects, all right, we are on our farm, right? We are on our farm. We need to create a system to keep track of all of our animals, right? And so we're building the system to keep track of all of our animals. We're noticing that all of the dogs have some similar things. All of the cats have some similar things. All the cows have some similar things, right? Maybe the feed is different between each animal. Maybe the location where they're kept on the farm is different between each animal. Maybe there are a lot of these things that make dogs very similar and cats very similar, but they all kind of share a lot of the similar things, right? All of our animals will have a name on this farm. All of our animals will have an age on this farm. And so we could say, you know what? Well, we're going to wind up creating all these different kinds of animals. So maybe what if there was some way to make sure that every animal in our system had some base set of properties and methods, like the things that every animal is going to use, right? Like every animal is going to use, right? Like every animal on our farm is going to have a name. Every animal on our farm is going to have an age. Like every single animal is going to have some base properties and methods. Then we noticed, all right, so we just started using animals to keep track of everything on our farm. But then we realized like, oh crap, like we really need to pay a little bit more specialized attention to the cows. The cows have some different requirements than all the other animals. Like the cows need like pasture. The cows are farting too much, right? Like there are some special things we need to keep track of, right? With the cows. But the cows are still some sort of animal. So if you ever start to find yourself creating a number of objects that have similar features, that's us right now. We have like dogs we need to keep track of, cows we need to keep track of, cats we need to keep track of. Then creating a generic object type to contain all the shared functionality. So that's kind of just creating our class, right? If we look at our class, we have a class that has shared functionality. All the animals can speak. So that's our generic class. All of them have the ability to speak. We want every animal on our farm to have the ability to speak. Cool. And inheriting those features into more specialized object types can be convenient and useful. Inheriting those features in more specialized object types can be convenient and useful. Okay. when I am creating a cow, I don't want to throw out the name. I don't want to throw out the speak. It'd be really great if every cow that I created could have a name and could speak. Also, when I'm trying to create dogs, it'd be nice if all the dogs had a name and they could all speak, right? I don't want to have to throw out, right? I don't want to have to throw out all the goodies I got from the animal class. I want to be able to use them, right? I want to be able to use them in these other classes that I'm creating, right? My Texas Toast, woo! Thank you for the 6 months. I appreciate you being here. It is awfully convenient and useful, right? So we can see now that, like, hey, if we're going to start creating a bunch of dogs and a bunch of cows and a bunch of chickens and a bunch of whatever, we don't want to have to constantly be also redoing the name and speak. It'd be great if there was a way that all the dogs we create could have those values, all the cows we create could have those values, but still have the things that make them special. And so what this does is it enables us to eliminate a whole bunch of redundant code, right? Imagine if I wanted to create dogs and I wanted to create cows, but I didn't have an animal class that they all extended from. Then every dog would also need to also be given a name, would also be needing to be given the speak method, right? So my dog class would have like an extra 6+ lines of code, right? For creating the dog. And if I'm going to be creating a bunch of different animals, I don't want to be repeating that same chunk of code over and over again. I don't want to have to give cows the ability to have a name and to speak. I don't want to have to give dogs the ability to have a name and speak. I don't want to have to give my chickens a name and the ability to speak. I don't want to have to give my, I don't know what else is, my horses the ability to have a name and the ability to speak, right? I am saving so much code, so much redundant code goes in the garbage can. It makes me so excited not to have to ever repeat this line of code here and this line of code here on anything that I extend. Are you excited? Are you excited about the ability to just wipe out a bunch of redundant code? Are you excited? Because I'm excited. And you know why I'm excited? That's inheritance, baby. We just learned about inheritance. That's what we just did. We just inherited. That's what we did. The animal class passed down. Passed down the name. Passed down the ability to speak. Our dog inherited the name. Our dog inherited the ability to speak. We don't have to repeat. We don't have to repeat. Inheritance, baby. That's what we just did. Inheritance. Yeah, that's what we did. You did it. You learned about it. You understand it. You used it. It's inheritance. Woo! Oh, let's beat drop. I'm proud of yourself. You just learned about inheritance. Let's go. Can I inherit a job now? I inherited broken eardrums. Wait, so the function is also inherited without super called on it, or was it called on it? So we'll see this in a second. We're gonna see what happens with the methods here. We're gonna see that exactly in a second. I got you. All right. Whoa! Thank you for the 1 month gifted sub. I appreciate that. Thank you so much. Cool. All right. And as with all of this stuff, you should definitely open up an editor and start playing around and trying to break all this stuff. All right. So here's my one sentence inheritance. Make a class from another class for a hierarchy of classes that share a set of properties and methods. What? Hold on. Make a class from another class for a hierarchy of classes that share a set of properties and methods. Now, I know that sounds like a mouthful. I know that sounds like a weird thing to say, but it's what we just saw. We had this omega class called animal, and we extended it to dog. And when we extended dog from animal, we got the ability to speak. We got the ability to have name. We got all these goodies from the parent, right? We got all these goodies from the parent that we're able to use, and we don't have to repeat ourselves over and over again. We can extend it, get all the stuff that we want, right? And not have to repeat our code over and over again. And you can eventually extend quite a bit here. So let's say we have animals on the farm, but let's say we have like domesticated animals and we have wild animals. Like we have like coyotes that run around on the farm. So we could have animals as a class. Then we could have an extension that's like all of our domesticated animals that have names and all of the wild animals which don't have names, right? And then inside the domesticated animals, we could have dogs and cats and chickens. And inside the wild animals, we could have our coyotes and our wolverines and all that wild stuff. So you can start to have like these really nice hierarchies of classes where you're just sharing down properties and methods, right? So that's kind of the idea here. All right, let's make a child class. I want you all to practice this. We're gonna put a few minutes on the clock here. But actually, let's take a break first. Let's take our break. When we come back from break, we're going to actually build a child class together. You're going to do that extension together. You're going to make your child class from a parent class. So let's go ahead and take our break. We're going to put 5 minutes on the clock. 5 minutes on the clock. Alrighty. As always, we're here in this for the marathon, for the long haul, for our career. We're going to be healthy. We're going to take a break. If you're able to get up and stretch, please do. If you're able to kind of maybe move your hands around a little bit, loosen them, wiggle them, and that's a good thing to do. If anything else, just let your eyes relax somewhere else that's not the screen. Let's go ahead and take 5 minutes, folks. Squats time. Hey. Alrighty. Let's put some break music on here. Alrighty, folks. 5 minutes. And we'll be back. We're gonna get some practice here. We're gonna start using the encapsulation. We're gonna start using the abstraction. We're gonna start using the inheritance, and then we're gonna get to the last of the pillars today. Man, so with the hydration, cheers to you. I'm gonna dip into my devil's elixir here. Thank you all for being here. I appreciate you showing up, putting in the work, pushing your brain to understand these hard concepts. Go ahead and folks, take that break. Pull stuff up over here on my end. Alrighty, folks. If you're able to, please go take a break. Rockefeller Nerd said, how can child classes use inherited combined classes? So it's possible, Rockefeller. There's a couple different syntaxes for doing combined inheritance. Some people will use something called mixin. Some folks will use like a parentheses syntax, but it is possible. It's definitely something that if you ping me on Discord, I can show you. Maybe during like an office hours, we can bust out an example. Yeah, we're gonna do some basic inheritance tonight, and then we can handle kind of those edge cases if you want. Did you hear about Top Shot? No, what is that? Make me hip. What is it? I did learn an amazing fact, I think yesterday. Digital NBA cards. Get out of here. Get out of here. That's That's the wave, huh? I did find an amazing NBA fact. In chat, I'm curious if anyone knows this. I know we're on break. If anyone knows this. How many 3-pointers did Shaq make in their entire career? Shaq. How many 3-pointers did Shaq make in their entire career? Oh, a lot of people are hip. A lot of people knew. It was 1. Shaq made 1 3-pointer their entire career. 1. I think that's wild. They had like what? It was like a 52% free throw percentage too. Yeah, 1. And it's when Shaq was like little Shaq, because Shaq got massive as things went on. But yeah, 3-pointer. Yeah, Scott, I've kind of looked into that world. I looked into that, like the digital token world when CryptoKitties was a thing. I always thought that was pretty cool. I always wanted to make like a crypto version of Pokemon, like with battling and everything. It's always been something I've like always wanted to figure out as like a play project. And like when you battle, like you actually like win crypto or something like that. I think that'd be a really fun project to build on. Kind of like what Temtem is doing to build their own kind of like Pokemon, but on top of blockchain. I think be dope. All right, folks, you got 10 seconds left. Thor, I couldn't see what you said. he got blocked, I think. All right, come on back, folks. Hope you had a good break. Hope you're able to relax a little, do that stretch, kiss some babies. Let's come on back, folks. All right. So, I'm gonna chill the music here. All right. I am back. Let's go. All right. So what I want you all to do is there was some starter code for this evening. Inside of that starter code were two folders, and one folder was the objects child class. What I would like for you to do is I want you to think of any like real world object that could then have an extension, that could have a child class. So I want you to go ahead and practice using the class syntax to create the parent class. And then I want you to try extending a child. I'm going to let it be real open to you. Pick whatever you want. Go ahead and try it. Play around with it. See what works, what doesn't work, and try getting it going. You definitely read about some of this in the reading, so go ahead and trying to get this to work. I'm going to pull back up my code so you can take a look at it while you're working on this. But yeah. I'm going to go ahead and put 5 minutes on the clock here. We're going to leave this nice and open for you. Pick whatever you want. Maybe any of the classes that we talked about before could be good, like the Street Fighter character, the Tony Hawk characters. I think those could all be like good options here. But I'm going to go ahead and put 5 minutes on the clock. If you're new here and you need the starter code, !Discord in the chat, that'll get you access to our Discord community. Agree to the rules, and then there's a Fall in Love Materials channel that has all the starter code for this evening. So this is just a nice kind of open exercise. Yeah, you can. I like the car one. That's a good idea. It's a cool one. Property, building, house. Cool. I like it. Miriam. Yeah, the reading. Haha, nervous smile. Hilarious. All right. Go ahead. You got about 4 minutes, 30 seconds. You can do this. Make it work. Cool. Let's put some break music on. Well, sorry, let's put some work music on for you. A class Hogwarts. Hey, that's a good one. I like that. Chaos mode, not tonight. We'll definitely hit on some of this stuff, possibly later on. Yeah. If you just use super, it'll give you everything just by itself inside the constructor, but you can also pass in parameters. Pi, this is object child class folder. Yes. Tara BZ, I'm going with sports. Yeah, let's go. I think Emma B is my favorite. I like the Hogwarts. I didn't even think about that. That's dope. Man, I could have made all these examples Hogwarts. And this should be some exploration. This is some fun times. What works, what doesn't work. Break it, make it work. See what gets played with. Oh, Kent Izzle. Me and the fiance just ordered Girl Scout cookies, so we're going with that. Oh, love it. Man, I could use some Girl Scout. Oh, whew. No, Leon, you don't need them. Maybe just one. Just one Thin Mint. I don't know. Ooh, energy class with renewable and fossil. I like that. That's dope. Let's not talk about Girl Scout cookies. If you see the leprechaun, say yeah. Yeah, frozen Thin Mints. Definitely the GOAT. My favorite too. All right, about a minute 45 left. If you finished up, if you got it to work, if you're able to play with it, you're able to get something going. Ooh, subgenres of hip hop. Go ahead and put done. Go ahead and put done in the chat for me. Just want to see where folks are at. Oh, Rossi, sorry to hear that. Chaos mode, yeah, we definitely get to design patterns later on in program. Still confused on super. We'll talk a little bit more about it. Just enables you to grab all the stuff from the parent class. Yeah, all super is really enabling you to do is to like get all the stuff that was up here, right? So this like name stuff, it just enables you to grab all that and use it down here. That's all. So that when you pass in a dog and you pass in Simba, you're actually creating the name. That's all. It's just saying like, hey, go grab all this stuff that was set on the parent. Here's where I get stuck. When something deserves to be its own class rather than a property of a parent class. So I think that comes down to really thinking about your code as like real physical objects, right? If you can think about your code as real physical objects, like you would say that like, all right, well, if I am creating a lot of one object, then it's probably time for its own class. Like if I only ever have one animal to deal with, it might not make a lot of sense to break down into every animal known to humankind. But if we're managing a farm and we have like 10 or so different types of animals that we're always dealing with, it's going to make more sense for us to have a class for each of those 10, just because it enables us to like treat them a little bit more special, give them the properties and methods that they need. Yeah. But there's like a lot of this OOP stuff is really hard for new developers to wrap their brains around, because they don't actually have to use it all the time. Like you can squeak by not using this stuff, but when you get dumped into a larger code base or you start working on your 100 hours project, you're going to want to have this stuff to kind of keep you from going wild, right? If the property and the value are the same, can you use the shortcut and use the value dot name? I'm not sure what that question is. Sorry, if you could clarify a little bit more, I can maybe help answer it. Oh, I see what you're saying. So in the example from the slides, we use super keyword just for the name props, and then this keyword for the breed props. That is what is confusing me. So let's talk about that. All right, folks, welcome back. Hope you had a chance to work on this. I'm going to chill the music here. All right. So we have this animal class, which is our parent class, right? Animal is our parent class. And then extending the animal class is our dog class. And this makes a lot of sense. Like if we're running a farm, we're going to have a bunch of animals, and we eventually want to be able to like encapsulate all the things that each animal needs inside of its own class. We don't want to lose the stuff that every animal needs. Like every animal needs a name. Every animal needs the ability to speak. We don't want to have to lose that. So we extend from animal to get all of those goodies. But now that we have our own dog class, we can start to add the things that make the most sense for a dog. And so one of the things that we add right away is a breed, right? Dogs have breeds. And so that's one thing that we add. We could also add anything else that a dog might have, or we might need to keep track of, that maybe another animal might not, right? What's something that a dog might have that other animals might not? Ooh, they might bark. They might have a tail. Dog smell. Fangs. Right? Tricks. They might have a tricks property that's like an array. Love. Right? So there are all these things that we could think of. Tails, fangs, barking, dog smell, tricks, right? All these things that we might want to include on our dog class that wouldn't necessarily go on all the animals. And something that might make a dog different than, say, like a cat or a cow, right? And so that's kind of where like this child class comes in. We're able to get all the goodies from the animal class, but all the stuff that we need, right? All the stuff that we need to be more specific and encapsulate all of our data and functionality around this idea of a dog. Yeah, cool. So let's code one of these out here. Well, let's talk through this one. I think talking through this one is really helpful. So we have our class animal, we have a name property, and it has the ability to speak. If I was to grab this and I put it into my text editor here, sorry, my console here, and I do Simba, we're going to see, of course, that Simba has a name. We're going to see, of course, that Simba has a breed, right? But we can also do something like this, Simba.speak. And we see Simba makes a sound. Now, wait a minute. Did dog have a speak method? Did dog have a speak method? No. How did Simba get the ability to speak? Ooh, baby. Yeah, it was inherited. It was inherited, right? We inherited the ability to speak, right? We inherited the ability to speak from animal. Since dog extended animal, we now have the ability to speak, right? Now, I saw some other folks kind of saying like, all right, well, prototype or something like that. Yeah, like underneath the hood, how all of this is working is that prototypal inheritance. But for right now, let's just say, like, yeah, it inherited the ability to speak from the animal class. That's it. Let's go ahead and play with this a little bit. Let me go ahead and refresh. Let me paste this in. Let me get rid of kind of super name here. Let's get rid of super name here. I'm getting rid of the super name. Let's hit enter. All right. Must call super constructor and derived class before accessing this or returning from derived constructor. So we're going to get an error here when we don't use the super, right? Because we're trying to get access to this, like this up here. Like we're trying to get access to the name. And I think what makes it a little bit harder for folks to see is that, let me go ahead and paste this, is that it's just one thing up here. But we can imagine that this has a lot of stuff on it. Like it could have like this dot age, right? And then our constructor could have age, right? And we could do this, and so this would be age. And it could be this dot, all of our animals, I don't know. We're going to say since they're all farm animals, they all have a, they all come from the same farm. So farm name, right? So they're all going to have a this dot farm name, right? So as we start to add more stuff to the original constructor, we get all those goodies here, down here when we use super, right? So just by using super, right? Just by using super, I now get access to all of these things that are up here, right? And so now I can do name, age, and I can do farm name if I want, right? And I can pass all that stuff in here too. Name, age, farm name, breed. And I'm passing all this stuff in. And now when I run this, like I'm just gonna get rid of the Simba here for a second. So now whenever I create a new dog, right? Whenever I create a new dog, it's also going to create a name, an age, and a farm name on each of those dogs. So I got rid of these 3 lines of code and traded it for 1. And we can imagine as our objects get a little bit more complex, this stuff saves, right? This stuff saves us from having to repeat all of this code. We just go ahead and grab it, and now we can use it. That's all we're doing. We're just saying, hey, go grab all the stuff from up here and enable us to use it. Now, why might we want to use super, right? Why might we want to use super? We could go ahead, right, and just play here locally, but let's not worry about that. Why would we want to go ahead and use super? Well, if we bring back that last line, we bring back this last line. Are we creating an animal class or are we creating a dog class? Specifically a dog, right? And that dog inherits from animal, right? But we want to make sure that when we're using a new dog, that we're passing the stuff into what's going to be spit out here, right? This constructor is going to spit out stuff for the dog, right? And so the super is just saying, all right, instead of having to re-say this dot name, this dot age, this dot farm name, right? It's just one line. This one line saves us from having to repeat all of this stuff here because we're not calling animal. It has no idea like how to set the name, the age, the farm name, because we're not calling animal, we're calling dog. And so since we're calling dog and we're passing all this stuff in, we want to make sure that when we're calling dog, we're still setting all this stuff up. So it's like a fork off the main branch of animal. Yeah, I think you think of it like that. Exactly. All right. So here's one of these things. I think for a lot of folks, the super can trip you up. Play with it. When we get to Remo this evening, this should be one of the first things you and your group pulls up. What happens if we don't include a parameter? What happens if we don't use the word super? Play with this. Figure out what it does, right? This is something that you really need to play with and understand. So when you're in your groups tonight, I want you to make sure that you definitely review this set of code and you break it. You are all in the phase where you need to like get your hands dirty and break and play with this stuff, right? And so we're going to keep pushing, but the idea here is that we're able to have one parent class that we're able to extend and have a bunch of children that get all the goodies that came from the parent, but use it on the children. All right. Regro, there is a way to kind of get around some of the redundant syntax, but for now we'll keep this. I think it's a little bit easier to read. Did someone say we're breaking code? Where do you need me? I need you on Remo after class this evening. All right. All right. So by using these classes, we eliminated a bunch of redundant code. We made a child class. And let's come back to the farm now. Let's come back to the farm. I know you got a lot of questions. We're going to get into the nitty-gritty details of all this stuff on Thursday. We're gonna really break down super and all that fun stuff. Tonight's really about like the high-level concept. But after class, when we're in Remo, break the crap out of this stuff. See what it does. See what happens when you don't use super. When we do use super, right? All right. My goal is that we're gonna hit Remo probably within the next half hour. Yeah. Cool. All right, let's get back to the farm, folks. Let's get back to the farm. All right. We are all now workers at the farm, and new workers keep renaming our animals in our system. When the animals first come, right? When the animals first come to the farm, we give them a name. 100 farmers. we give them a name, and that's been working out pretty well. Except that some of the workers, for some reason, keep renaming the animals that have already been named. So let's go ahead and take a look at this. I'm going to go ahead and grab this code here. And I'm going to refresh. I'm going to paste it in. All right. If I look at Simba and I do Simba.name, I get Simba. But if I am just like in my code mucking around and I'm like, you know what? I want to change Simba's name to Bob. Right? And now I come back later and I'm trying to like access the dog's name. Oh. Oh my gosh. Did you all see what happened here? I went through all this trouble to encapsulate my data and my functionality. I am trying to use this encapsulated data and functionality to name all of our animals on the farm, right? Trying to use these objects to keep track of all the names of the animals on our farm. And some new dev on the team just like, you know what? I wanna rename Simba to Bob. And guess what? It breaks. It breaks, right? You were able to change the name. Now, if I ever use Simba somewhere else in my code, it might not be the right name, right? Like this is bad. This is what's going to keep me up at night. The fact that somebody can just very easily rename stuff, right? That they can rename stuff. Simba's not Bob, right? Simba's not Bob. Why the frick can they rename my stuff? Why can they rename it? What could help here? I'm angry. They keep renaming the animals that have already been named when they come onto the farm. Yeah. We can use, so here's the thing. Encapsulation and abstraction are very tightly intertwined, right? So we can use a little bit of abstraction here. We want to be able to like get the name of an animal, but we don't want anybody else to be able to like update the name of an animal, right? Like when they come in, they get their name and that's it. We don't ever want to have to lose sleep at night that some other developer on our farm system has like renamed stuff, right? We don't ever want to worry, right? And so abstraction can help us not have to worry about this anymore. We can abstract out like how the name, right? How the name gets like set and how we get it, and not worry about breaking anything about naming. We set the name once and we never have to worry about it again. We can consume the name as much as we want, right? We can use the name as much as we want, but we don't have to worry about like breaking some other area of our code. We can abstract that out the way. So yeah, we're going to use a form of abstraction here. All right, let's look at this code. This code's a little tricky here. All right. I'm going to run it and then we're going to come back and break it down. So I'm just going to go ahead and grab this bit of code. Going to come to our handy dandy little console here, paste this in, and let's go ahead and do simba.name. Boom, we got Simba. And then let's go ahead and do simba.name equals Bob. Cool. And let's ask for Simba's name again. And we see that they were not able to change Simba's name to Bob. Right? So the way that we set up this class now, we set the name once, right? We set the name to Simba, right? And now if somebody else comes along in our code and tries to rename Simba, they can't. You can see they tried setting the name equal to Bob, tough cookies, tough Girl Scout cookies. You couldn't change it. And now you can see that it's still Simba. Okay. So before we look at this code, chat, why could this be helpful? Why would this be helpful? Why would this level of like encapsulation of like keeping like your animal, like your data and your functionality together, why would that be helpful? And then why would like being able to abstract out like what's happening underneath the hood here be helpful? Let's not really think about like security or privacy here. Let's think that we are working on a team of other developers and we all think that we're acting in good faith. So let's not worry about like privacy or security. Let's just say that we're developers, we're software engineers working on a team. How does this help us? Yeah, Ben Train keeps the code from breaking and a new dev from accidentally making changes. Enables us to avoid like data overwriting. Exactly, Hadoken, right? Others won't change squat. take stuff out of the equation. We won't break stuff. Yeah, this is all coming back, right? This is all coming back to this idea, right? It's all coming back to this idea that we want to be able to sleep at night. We want to know that once we set up our code, it's not going to be broken down the line. When we set up our code, we can rest easy knowing that some other developer isn't kind of messing up all the hard work that we've done. Just like with a car, we want to get into our car and just use the steering wheel. Pumpkin Days, hey, thank you for the sub. Really enjoyed the raid last night. Love the Pumpkin Days project. Pumpkin Days looks like to me like what the new Pokemon's gonna be, but you did it, and it only took Game Freak 25 years. So I think that's hilarious. That it took them 25 years to get there, and your game's already out in the market. People can go play it right now, and it's exactly what they're trying to do. They ripped you off. They stole your aesthetic. But yeah, the game looks dope. All right. So we're in this idea, right? That all this OOP stuff, all this object-oriented stuff is not just because we want to be some like nerds or some academics sitting up in a tower. It's that this OOP stuff can like actually have a real measurable impact on the code that we write and how we work with other developers and even ourselves down the line, right? Now, what this is going to do is save me from making some errors down the line, or save like other developers from kind of messing with my code. Remember, I want to sit down in a car and just turn the steering wheel. I don't want to have to know how all of the engine and stuff is running. When somebody comes and uses my animal class, I want them just to be able to get the name and not do anything else. I don't want them to like have a button on the steering wheel that says like drop all the oil. I don't want a button on my steering wheel that says like redo like the piston height or something like that. We abstract all that out. I want users to be able to come and use this class, not worry about what's happening, so that they can just make the changes that they want to make and not worry about breaking anything. Okay. All right, now let's take a look at the code. Let's work through it. All right, we're going to notice something different here. Our constructor is using this underscore. This underscore is just a common thing. It's not doing anything automatically. It's just so we know that we probably shouldn't touch this, that it's going to be private to this class, like that it shouldn't be publicly accessible. Like you shouldn't be able to make modifications or changes to it. That's when you see the underscore. Okay, when you see the underscore, it's like, hey, like if you're changing this, like you're messing up, my friend. Don't go ahead and change this, right? So we have this underscore here, and what happens is when we create Simba, which is using the animal class, we pass in Simba. Simba gets plugged into the name, right? Simba gets plugged into the name. So now this underscore name is set to Simba. Cool. Now, if you look, there's a speak method that's using it, right? We're able to use that property inside of our methods, no problem. But we have this getter. And this getter says, all right, just return this dot name. That's all it does. All this does is returns this dot name. So that when we actually come down here and we do this dot name, what we do is we're invoking this getter. We're telling this getter to run, and that's why we're able to get Simba. Now, why this is important, is because we're able to use like this syntax here, like this big glaring red flashing light. Don't touch this, don't touch this, don't touch this, right? We're able to use that. But the users of my object have no idea this is happening behind the scenes. They have no idea that I'm trying to keep something private. All they see is when they say Simba.name, they get Simba back. They don't know that I'm trying to hide stuff from them. They don't know that I have like this funky like syntax thing here. I have abstracted that away from them, right? I've abstracted this away from them. The underscore is just that we know that this is going to be like private, that they shouldn't have access to this. Because like, let's go ahead and look now. Let's go ahead and look and actually see like what's happening here. All right, if I do Simba.name, I get Simba, right? If I try and go ahead and do Simba.name equals Bob, and I ask for Simba.name back, it's still Simba. Why? Why didn't this work? Chat, somebody tell me why this didn't work. That's the big piece right here. If we can figure out why this didn't work, we're in a good spot. Why didn't this work? Is name actually a property, right? Is name actually a property here? Let's go back and look. Let's go back and look. No. Name is not a property here. We can see that it's a method, well, a special kind of method, a getter. We can see that it's a special kind of method, a getter here, right? And if we actually look, the actual name property is not name. What is the actual name property here? What is the actual name property there? Yeah. So when we go back here and we say Simba.name, are we actually changing any property? Are we changing any property? No, we're not changing any property. There is literally no property, right? There's no property name here, right? There's no property name here. Like if we go back and look, the property is not actually name. It's underscore name, right? And then we are kind of taking up that namespace. We're taking up that name with our getter, which is going to pull this value out, right? So when they go ahead, when the other developer on my team goes ahead and tries to like change the name, there's nothing for them to latch onto. There's nothing for them to latch onto, right? There's nothing for them to latch onto. Name is already being taken up by the getter, right? Name's already being taken up by the getter, right? Name's already being taken up by the getter. And the actual property that they would be trying to change isn't name anyway. It's underscore name. Cool. Now here's something interesting. This is why I said don't worry about security. Worry about like practically working with another developer. You ready? All right. Why would no good developer ever do this? Why would no good developer ever do this? Congratulations, you played yourself. Why would no developer ever do this? Yeah, exactly. I like that, Shell. This underscore says no touch. Do not touch it. Run away. Don't touch it. Nope, 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 nope. Don't touch. No touching. Don't touch. No touch. No touch. Right? So when you see that underscore, it's not doing anything special. It's just letting you know that you shouldn't mess with it. Don't touch it. Right? Don't mess with it. Don't touch it. That's all it's saying. And so if we buy into this convention, then we can start to use, right? We can start to use our encapsulation and our abstraction very nicely. But a lot of this stuff isn't so much like forced in JavaScript. It's a lot of conventions as well. And so this is one of those conventions that you got to stick to. When you see that underscore, you don't touch it. It's private. It shouldn't be revealed to the user. All right. And when I say user, I don't mean like our users that are downloading the application. I mean like other developers. Sleek, thank you for the 2 months. Hey, I appreciate that. Thank you for the 2 months. Thank you for being here. All right. Tone with the hydration. Cheers to you. Alrighty. Don't undermine the underscore. Just about with the hydration as well. Cheers to you. Alrighty. Let's keep moving. Alrighty. One last concept tonight. I know this is some hard stuff to deal with. You're going to get some practice. You're going to break into groups. You're going to talk through all this stuff together as well. Right? The hard stuff here is like putting it into practice. Like you can listen to me ramble and all, but it won't really make sense until you're playing with it, until it's in your hands, you're breaking it, you're being like, all right, let me try and encapsulate some data. Let me try to abstract some stuff. Let me see if I can inherit things. And we got one more thing that's on our plate. Okay? One more thing that's on our plate. Okay? So what happens when the team doesn't use the underminer? We take them outside. Alrighty. Let's say we're on the farm. We're on the farm. And we just rescued a whole bunch of animals. A whole bunch of animals. How should we build out our system? Right? If we just rescued a whole bunch of animals, how should we go ahead and build out our system? We know that we're going to have some animals. We know that we're going to have some cats. We're going to have some dogs. We're going to have some cows. What are some ways that we can go ahead and build out our system? What are some things that you're thinking about when we say, all right, we know we have to build some sort of tech system to keep track of all the animals on our farm? What are you thinking about? What should we be using? All right, I like having some base animal class and then extending it for each of the animals. I like that. Making sure people can't, maybe we have some things that are abstracted, right? Maybe we have some things that are abstracted, like the name, right? The name gets abstracted. So once an animal comes into the farm, we can't touch their name. Cool. I like that. I think that's a really good place to start. I think having like a base animal class and then maybe let's do like 2 subclasses or 2 children classes, like 2 child classes, like a cat and a dog. So let's do that. I actually have it here already in this complete, but we're gonna build it out together. So we're gonna take a quick glance, right? We have our animal class, we have our constructor, we have our name, we have the ability to speak, and then we got some other stuff for like a dog class, and we got some other stuff for a cat class. But let's go ahead and build this out together. So I'm just gonna go ahead and comment this out real quick. And save that. Whoop. Oh, I just did a, there we go. All right, so I'm going to comment this out. I'm going to save it. I'm going to come up here and give myself some room. All right. So we know we have a bunch of new animals coming into the farm. We want to build a system so that we can start keeping track of them, knowing, we really want to know like what their names are, and we want to know what sound they make. We want to be able to like hear them on the farm and know, all right, that's the dogs, that's the cows, that's the chickens. We're really worried of like hearing like wolves or stuff like that. So we want to make sure that they all have a name, because this is a loving farm, and we want to make sure that we know what kind of sound they all make. All right. Let's go ahead and try this out. So let's go ahead and do class animal. All right. And let's go ahead and give our constructor. And our constructor is going to take in a name. Cool. Now, we know that we don't want the name to eventually be able to be reassigned anywhere else in our code. We want to be able to abstract away the name so that it can only be set once, and then we're only consuming the name. We're never like updating it, changing it, or anything like that. So as soon as I know that I'm only going to ever want to like set it and then forget it, and I know that I'm never going to want it to be like revealed anywhere else in my code, what am I going to use here? What am I thinking through? Underscore that baby. Hey, let's go. Topher tries. Thank you for the hydration. Cheers to you. Thank you for the hydration. Cool. We're gonna lean into this idea of saying something like this dot underscore name equals name. Cool. If we were to like just call this constructor right now, we could say let Simba equal new animal, and we could pass in Simba, and this would work, right? Like we would see that Simba would go into name, and then there would be like this name underscore name property for Simba. But we're gonna keep going. We want to build out a few other things. The other things we want to build out are, now that we said, all right, this is gonna be private, it's not gonna be revealed anywhere else in our code. We should be able to get it, but we should never be able to touch it. We set that up. Well, now we need to be able to get it, right? So we're gonna set up our getter, get name, and all that this is going to do is return, right? All it's gonna do is return this dot underscore name. That's all our getter is gonna do. It's gonna get. That's all it's gonna do. It's gonna get. Going to get that underscore name and return it. Now, the last thing I want to do is I want each animal, every animal that's created, to have the ability to speak, right? I want it to have the ability for it to speak. So we're going to go ahead and have a speak. What does this do? This is what's binding this property to the object that comes out of the class. Without this, we couldn't actually put these like properties and methods on the object that's coming out. That's all it's doing. All right. So we're going to have a speak. So we're going to do our console.log, and we're going to put a template literal in here, and we're just going to say, all right, we're going to call the name of whatever it is. So we're going to say this dot underscore name makes a sound. Cool. Makes a sound. Makes a sound. Makes a sound. Alrighty. So now we have a lovely animal class. Every animal that comes to our farm will have a name. And that name, right? That name should only be able to be gotten. You shouldn't be able to like actually set the name anymore. We're just going to go ahead and get that name. And each animal that comes out the farm will have the ability to speak, which is pretty cool. So let's go ahead and now we say, all right, so we have our base animal class, our parent class that has the goodies. It has this name that we don't ever have to repeat ourselves again. And it has this speak that we don't ever have to repeat again if we don't want to. And you could imagine that if we were building this out for real and we had like a lot of animals, our animals are all going to have a lot of stuff like ages, right? Our animals are going to have a bunch of things that we'd want to be inherited through to our other like subclasses or our children. But for right now, let's just keep it simple. Let's just keep a name. And we're going to say everything that comes from this animal is going to get the benefit of at least having a name. Cool. All right, so let's go ahead and set up a new class called dog. And we're going to extend animal. Cool. Class extends animal. And what we're going to do is we are going to go ahead and say, all right, we have it down here so we can see it all in one go. We're going to have a breed that gets added. We're going to make sure that we kind of abstract out the breed. And we're going to have two different types of things here that are going to be helpful for us to see down the line. We're going to grab the speak from the parent, and we're going to also give it a bark as well. So let's go ahead and do this. Let's set up our constructor. Cool. And our constructor is going to take in some values. It's going to take in a name. And it's going to take in a breed. Cool. It's going to take a name and a breed. All right. It's going to take in a name and a breed. And we're going to use this super. And all this super is going to enable us to do is to go ahead and get the goodie from the parent class. All right. It's just going to enable us to grab all this stuff that's up there on that parent. Now, right now, it's just one thing. It's just one thing. But we could imagine that it'd be a lot of things. And this one line, right? This one line could be grabbing a lot of stuff for us. Right now, it's just grabbing one thing. But in real life, it could be grabbing a lot for us. So for now, we're going to use it. It's going to grab the one thing. Cool. And then we're going to go ahead and set one other value. This dot underscore breed equals breed, right? And what are we noticing here? We're noticing, all right, what are we noticing here, chat? What are we thinking through here? No touch. Red alert. Don't touch. Don't touch. Exactly. Don't touch. All right. So if we can't touch it, but we want it, what do we got to do? We can't touch it, but we want it. Oh, boy. We're going to get it. We're going to get it. The soundboards that could be created from these classes. That's OnlyFans content. Exactly. All right. Not that kind of stream, folks. We're going to get it. We're going to get name. Cool. And all this is going to do is return this dot underscore breed. That's all we're going to do. We're going to get it. We're going to get it. This underscore dot breed just gets it for us. Sorry. Not name. Breed. My bad. Just gets it for us. All right. So now we are creating a new dog that extends animal. We have grabbed all the stuff from the parent. We set up something special for our dog, which is a breed. And we've made it so that we don't touch it, but we can always get it and use it. We're abstracting it out so that we don't have to lose sleep at night about somebody messing it up and reassigning the breed. They should have the same breed they came in with. The breed's not changing during the course at this farm. I really hope not. Hope we don't have some sort of genetic engineering going on. Cool. All right. Last thing we want to do is we want to have a speak again. But I want to show you something interesting about this speak. So what I can do is I can go ahead and say, you know what? I want the speak from the parent animal. Like if I want the speak from the parent animal, like I want to be able to see that I want to see that with my dog. Like, we know that there's already a speak. Like, if we didn't have this, right? If we didn't have this, right? It would just use the speak from animal, right? So we don't need a speak on dog, except that, you know what? Maybe I want a dog to do what? What do I want a dog to do? It's different from other animals. What do I want my dog to do? Yeah, I want my dog to bark. So I want to give it the ability to bark, right? I want to give it the ability to bark. And so we're going to go ahead and we're going to do another speak here. And this is setting up something for us later on, but I'm going to go ahead and set up a speak here. If I still want to use the speak from the parent, I have access to it. I can do super.speak. That'll grab the speak from the parent. So that would grab this console log right here. But I can also go ahead and give myself my own speak, where I can also do a console log. And I can go ahead and say same thing. Go ahead and say the same thing. I can say the same thing here that I had above. I can go ahead and say it again. I can say this. This dot name. And we can say barks. Cool. This dot name barks. Cool. And there we go. So now we got something going on here. We're cooking here. We got an animal class that by default has a name that we're saying don't touch. We reveal it through our getter. And we also have the ability to speak. And so every animal that comes from this class will have a name and the ability to speak. Now, the interesting thing here is I have decided inside of my dog class, to not only grab the original speak, but to create my own for the dog, which is barks. Okay. Now this is not like a normal pattern. This isn't something you would always see. Normally you probably just have like the speak and you would just use it from the animal, and you'd be really happy with this idea that like, all right, Simba makes a sound and we'd be good with that, right? Oops, sorry. But here we're going to use not only the original speak from the animal class, but we've also given it our own. So let's actually see this now. Let's actually see this. Let's put this into play. Let's actually see what's happening here. Let Simba equal new dog, and we're going to pass in the name of Simba, and we're going to pass in the breed of shepherd. Cool. Let's save this. Let's go ahead and get this running. All right, and let's ask for Simba. We can see that we have a Simba object here, right? We have a Simba object. And if we do Simba.speak, we get two things printed to the console. We get two things printed to the console here. This is why I wanted to do it here. We got two things printed to the console. We have the original Simba makes a sound. And we have the Simba barks. All right. Simba makes a sound and Simba barks. Let's go back and take a look at the code. We said, all right, let's go ahead and whenever you see super, chat, whenever you see super, what are you doing? Whenever you see that super, what are you doing? Grabs from the parent. Exactly. It's going to go grab from the parent. It's going to go ahead and make sure that we're grabbing that stuff from the parent. All right. It's grabbing from the parent. So when we see the super.speak, what we're actually doing, when we see that super.speak, what we're actually doing is going up and grabbing the speak on the parent. That's why we're able pulling a fat Joe going all the way up. That's why we're able to see the Simba makes a sound. We're able to see the Simba makes a sound because we said super dot speak. We said super dot speak, so it went up to the parent. It went up to the parent and it grabbed that speak as well. Then we also had our own. Name barks, right? Name barks. And so if we go ahead and we look, Simba makes a sound. We saw that. And we saw Simba barks. Cool. Cool. Let's create another one. Let's create another class. Let's go ahead and I'm going to go ahead and do class cat extends animal, and give me a little bit of freedom here. We're gonna see some stuff that we're gonna talk about. All right, we're gonna have a name again and a breed again. Whoop. So we're gonna do super with the name again, and we're gonna do this dot underscore breed. And we're going to set it equal to breed. And we're going to go ahead and set up our getter. Does this feel weird to anyone? Does this feel a little weird? All right, we're going to get the this dot breed, and then we're going to have a speak. We're going to grab the super speak as well. And we're going to also console log its own thing. So let's go ahead and console.log and do the same thing again. This dot name meows. That just felt weird. That felt weird the whole time. That felt weird the whole time. What are we noticing as we're going through this? What are we noticing as we start to add different types of animals? We have like our dogs now, our cats now. What are we noticing? Yeah, I'm definitely repeating myself. What's one way that I could get rid of this repetition? How could I get rid of this? Let's think about the objects. Cats and dogs are probably very similar. Do all of our animals have a breed? Tara BZ with the hydration. Cheers to you. Thank you for the hydration. Do all animals have a breed? Or is it only domesticated animals that have a breed? Like husbandry, right? Like animals that we as humans put selective pressure on. I don't know. Does every animal have a breed? Or is it just like animals that we've put selective pressure on? All right, so here's some questions we have to think through. If we think that every animal has a breed, where should breed be? If we believe every animal has a breed, where should it be? Yeah, now we're thinking. Let's go. I love seeing that. Fuck yeah, let's go. If we think every animal has a breed, then we should be putting that on the animal class. That way, every animal, no matter whether it's a cat or a dog, it has a breed. Right? Let's go. We're getting this stuff. Oh, I love it. Let's go. We should just put it on the animal class. If everything should have a breed. But let's say we put our science hat on for a second and we say, wait a minute, only domesticated animals have a breed. Only like animals that like we have like husbandry, like that we've like put through like our process of raising them and putting our own selective pressure on them. Only those have a breed. So if we came to the conclusion that only animals that we've domesticated have a breed, what would we need then? What could we have done then? Yes. Yash. Got it right. We could have an animal class. Right? You could have an animal class. And then we could extend the animal class to be domestic. And we could also extend to be wild. That way, all of our domestic animals would have a breed. So then when we created our dogs and our cats that extended domestic, not only did they get all the wonderful stuff from animal, they get all the wonderful stuff from domestic, but then we could they also got like all of the like breed and stuff that would be for domesticated animals. We could also have a wild class that, right? A wild class that extended animal. But that wild class, anything that extends from that would never have a breed or anything like that. So the idea here is that we could start thinking about our code in terms of like real objects, right? And we can encapsulate our data and our functionality into one thing. We can abstract away the stuff that we don't want to have to lose sleep over at night. And then once we really start thinking about objects, we're going to start to make some like serious decisions with our code, right? We're gonna make some serious decisions with our code. We're gonna say, should we have a class that extends another class? Like, how should we put all this stuff together, right? So that's where I want you to get. I want you to get through where you're starting to realize, all right, I might have to think through this a little bit. I might have to think about, all right, what's gonna be my class? What inherits from that class? What's going to be on that class as opposed to another. And so I want you to start feeling like you can start to think through these decisions. Couldn't you also just put it on the animal class, and if a class that is extending from animal could just leave out the parameter on the super? Not sure what that means. Couldn't you also just put it on animal class? Just leave out the parameter super. Not sure. I think we're gonna get to that in a second. Actually, All right. Let's come back. All right. So we've built out the ability to have an animal class. We extended that into dogs and cats, right? And I'm just gonna go ahead and delete all this and just uncomment the one I have down here. All right, I'm gonna uncomment the one I have down here. Same thing, just I already wrote out a couple here. So here, I'm going to start using these classes that we've extended, right? Sorry, so if you put a breed on the animal class, but a new class extending from animal, let's say a bug or something doesn't have a breed, that you just leave the breed parameter out. So I would say that's not, like, you'd want to think through like how you are extending your classes. To me, you wouldn't want to ever have some things that would or wouldn't be on a class. You'd want all your classes to have those values, right? And then you would have your extensions to cover the things that you wanted to add on top. So I think it's just a way of thinking or organizing your code, not so much like a practice or tied into the language. Yeah. All right. So here I have Simba, where I'm creating a new dog. I have Mashi, where I'm creating a new dog. And I have Salem, where I'm creating a new cat. All right. Let's go ahead and grab all this. Let's copy it. And I'm going to go to my browser real quick. I'm going to give myself a refresh. I'm going to paste it in here. All right. If I ask for Simba, you can see I get a dog back. If I ask for Mashi, I get a dog back. If I do mashi.speak, how many things are we going to see in the console? If I do mashi.speak, how many things am I going to see in the console? I'm going to see 2, exactly. I'm going to see 2 things in the console. Boom. The machine makes a sound, and the machine barks. Right? The machine makes a sound, and the machine barks. Let's go back and look at this code. We can see that we're going to use the dog class. We're going to use super to go and grab this speak on the animal class, which is the parent. And then we have our own barks. Cool. We have our own barks. Nice. All right. If we go ahead and we use Salem, we're going to see the same thing with Salem. Salem, right, dot speak. We can see Salem makes a sound and Salem meows. Cool. Don't worry about the undefined. It's just kind of like the Chrome browser doing its thing. All right. So we got classes. We've extended our classes. We were able to like set some stuff that are abstracted out the way. We were able to not only go ahead and grab stuff from the parent, but also create our own. Let me throw one more thing into the wrench here. One more thing that I think is really important to see. And it's this last part right here. It's this last part right here. So I'm just going to go ahead. I'm going to save. And I'm going to refresh. And we're going to see something here. Simba makes a sound. Simba barks. The machine makes a sound. The machine barks. Salem makes a sound. Salem meows. Let's go ahead and take a look. We have farm. What is farm? Chat, what is farm here? What is farm here? It's an array. And the array is holding what? The array is holding a bunch of what? It's a bunch of objects. Yeah, exactly. It's an array holding a bunch of objects. Now, are each of these objects different kinds of objects? Like Simba and Mashi are what type of object? Where do they come from? They're both dogs. And Salem is a what? Salem is a cat. Okay. So they're all different types of objects. They're all different types of objects. Interesting. They're all different types of objects. Let's keep that in mind. All right. They're all different types of objects. So we want to do a morning roll call. Unfortunately, Dr. Doolittle works on our farm. Right? We want to do a roll call every morning. We want the animals to do. We want to hear them speak. We want to hear them speak, and we want to hear them speak in their own voice, right? And so we're very, very lucky that Dr. Doolittle works on our farm, and they can listen to the roll call and know who's here. Now, this is the code we just saw. What's making me feel? Why am I pausing on this? Why is this a little odd to me? Why is this a little odd? Why is that weird? They got polymorphed. All right, so two of the things that are inside of our array are dogs, and one of the things is a cat, but speak works on all of them. Speak doesn't care if it's a dog or a cat. It just works. They're all doing the same action. It just works, right? Like, even if it's a dog or a cat, it just works. They all speak. It doesn't matter that they're a dog. It doesn't matter that they're a cat. Our code works here. It does what we want it to do, right? We want each of the animals to speak in their own voice. We want them to use their own barking or meowing, right? All right. Let's read this. Let's read this real quick. Code written to use an interface automatically knows how to work with any number of different objects that provide the interface. The fuck? Hold on. Hold on. Hold on. Hold on. What? My brain. My brain. Hold on. Whew. All right. Code written to use an interface automatically knows how to work with any number of different objects that provide the interface. The fuck? What's an interface? Somebody tell me what an interface is. What's an interface? Like in real world. None of this like fancy programmy bullshit. What's an interface? A menu could be an interface. Yeah. A way you interact with something. I really like that, Blah. A way you interact with something. If I want to turn on the party lights, folks, you know how we do. You know how we do. If I want to turn on the party lights, I got myself a nice little interface here to turn on the party lights. If Bob wants to get funky, I got him. This is an interface for the party lights. All right, so I'm thinking of remote control here. That's my interface for the party lights. Code written to use an interface automatically knows how to work with any number of different objects that provide the interface. All right, so objects are providing an interface. That last part, different objects that provide an interface. We know that objects are providing an interface. What would be the interface for an object? What would be the interface for an object? Yeah, the things that get exposed to us, like the methods, right? The methods, the things that we see, those are the interface. That's how we interact with our object. And this is really important now because we do know of abstraction, right? What we see and what we can interface with might not be everything that object can do. Right? Like if the steering wheel is my interface for the car, there's no button to like blow up the engine, right? The car can blow up the engine at any time, but there's no button on my steering wheel that says like blow up the engine, right? That is abstracted away from us. Like the ability to blow up the engine has been abstracted. Cool. So all right, objects have an interface, which is just like the methods and the things that we're able to see and interact with. All right, so I think we're getting there. So the interface, like the buttons on a remote control, but the buttons for our objects are just the methods that we're able to use. Because some of them are abstracted and we can't see them or interact with them, and some of them are available as part of the interface. Cool. All right. Code written to use an interface automatically knows how to work with any number of different objects that provide the interface. Are our objects providing an interface? Let's go back and look at our objects. Are our objects providing an interface? What's part of the interface for this class object? Oh, I can feel the nerd shaking from here. Speak is part of the interface, right? It's part of the thing that like the object has, right? Yeah, so speak is part of our interface here. All right, so speak is part of our interface here. Let's go ahead and take a look. Code written to use an interface automatically knows how to work with any number of different objects. What type of objects do we have right now? What type of objects do we have right now that we're worried about? What type of objects do we have that we are worried about right now? Which ones are we worried about right now? Dog and cat. Right? We have two different kinds of objects right now. A dog and a cat. Code written to use an interface, so let's just say our speak method, automatically knows how to work with any number of different objects, our dog or cat objects, that provide the interface. Does the dog and cat provide a speak interface? Do they both have this speak interface? Yeah. Does the speak interface do something different on each of them? What does a dog do? What does the dog do? It barks. Cool. And what is the cat doing? Yeah, it's meowing. All right, let's look at that code real quick. All right. Okay. Code written to use an interface, so the speak method, automatically knows how to work with any number of objects. A is going to hold how many different objects? When this code runs, how many times is this going to run? How many times is this loop going to run? This loop's going to run 3 times, and it's going to use 2 different kinds of objects. A dog object and a cat object. Does this know how to automatically work? It doesn't matter if it's a dog or a cat, right? It doesn't matter if it's a dog or a cat. It just speaks. It uses the same interface, right? Dog and cat both have like this interface, and this code just works. It knows how to use it. Cool. What happens if one of them doesn't speak? Well, they all speak. How come every single thing that would ever be in this loop, will always speak? Why? Thank you, indifferent. We need you shaking. Yeah, because the parent has speak. The parent has speak, yes. The parent is getting this. We're doing this. They're getting it. They're learning. They're understanding. We're getting this shit. Fuck yeah, let's go. Let's go. Let's go. The animal has speak. The animals has speak. So they'll all eventually have it, right? They'll all eventually have it. Right? They'll all eventually have it. All right. All right. Next one. Sibling descendants of a base class will all have the same interface but varying implementations. What kind of shit is that? What the fuck? Why are they doing this to me? Who's writing this stuff? Why do they write this without explaining anything? Why do they write this? Why does every video just jump over this and never explain any of this stuff? Why every single thing you read, they just write that sentence and they don't talk about it. They don't tell me what it means. How dare you? I don't understand what this shit means. You're using big words. I don't understand. I'm going to treat it as disrespect. What was the reason? Exactly. All right. Hold on. Stay with me. Sibling descendants. What do we think that means? Sibling descendants. What do we think that means? Sibling descendants. What do we think that means? The child classes. Yeah, the children, right? The children. All right, sibling descendants. We're talking about children classes. We're talking about dog and cat. All right. Of a base class. What is our base class in this sense then? Think of the children. Base class is animal. Cool. All right. Why the fuck couldn't they just say that? What? Come on. All right, sibling descendants. We're talking about the children. Base class. All right, we're talking about the parent. We'll all have the same interface, but varying implementations. When we say interface, what are we talking about for right now? When we say interface, what are we talking about right now? What's the interface that we've been keeping in our head? Speak, right? Just like the buttons on our remote control, our objects have things that we can use, and we're using speak. That's our interface. But varying implementations. What does that mean? Varying implementations. Varying implementations. What is a cat doing different than a dog? Yeah, exactly. It's a meow versus a bark. A meow versus a bark. So, all right, let's run this back. Children of the parent class will all have the same interface. So in this case, the speak method, but varying implementations. So they could all have speak, right? That we know that every sibling class we make will always have the speak class. The speak method. Why? Why will every sibling descendant all have the speak interface? Yeah, it's inherited from animal. There's no way that anything we extend doesn't have that speak class. It's getting it from the base class. But varying implementation. So it could be the makes a noise. We know that it could just be makes a noise, or we could have in our extension changed it to a bark or a meow. Cool. All right, it's making sense. All right. Cool. All right. Code written to use an interface like speak automatically knows how to work with any number of different objects, like our cat objects, our dog objects that provide the interface. So they're all providing this speak interface. Cool. Sibling descendants of a base class will all have the same interface. They're all going to have speak because they all inherit from animal. Great. Of varying implementations. So it could be a bark, it could be a meow, or it could just be the base from the animal, which is makes a noise. All right. Deep breath. Everybody take a deep breath. Hold on. Come with me. In through the nose. Out through the mouth. We're going to do one more. All right. Cool. When you're not sure of the object's type at runtime and the most specific method is called, When you're not sure of the object's type at runtime, and the most specific method is called. This is really going to get the nerds a shaken. This right here, I can feel it. I thought it was an earthquake. It wasn't. It was some nerd at MIT just like flipping the desk over. Hold on. Am I wiggling? You see it? Am I wiggling? Hold on. I don't know if you can see it. Am I shaking? You hear them at MIT? You hear them? I can hear them too. It's shaking. And my camera's mounted too well. I'm not getting the shake that I want here. They're angry. All right, we're gonna let them be angry though. All right. This is whose line it anyway. We're making it up all as we go. All right. When you're not sure of the object's type at runtime, and the most specific method is called. When you're not sure of the object's type at runtime, the most specific method is called. All right. When you're not sure of the object's type, type is like a real big thing. Like we're going to have a whole class where we talk about types when we get to TypeScript. But for right now, let's just think about different types of objects. Let's just think about let's really grind their gears. Let's just think about different types of objects. What kind of objects do we have right now? What type of objects do we have right now? We got some cats. We got some dogs. All right. When you're not sure of the object's type at runtime, let's just say like when the code runs. It has the word run in it. So I'm just going to say when it runs. So when you're not sure of the objects, like if it's a cat or dog when it's running, the most specific method is called. What do you think that means? The most specific method is called. The most specific method is called. Yeah, maybe like the child's methods before the parents. Like we check the speak on dog and cat before we check speak on animal. Yeah, we're gonna. All right, yeah, that makes sense. So we have dog and cat objects. When it comes time to run them, we're gonna look at the most specific method first. So we're gonna run the most specific method first. We're gonna run speak before on dog or cat before we run it on animal. All right. Therefore, the behavior of the method called may differ depending on the object type at runtime. Therefore, the behavior of the method called may differ depending on the object's type at runtime. I think we can get this one. Therefore, the behavior of the method called, so it's just speak, may differ depending on the object's type. Like if it's a dog or a cat when it runs. All right, that makes sense. So the behavior of speak can differ depending on the object's type at runtime. So the speak can do different stuff depending on whether it's a cat or dog when it runs. That makes sense, right? Yeah, okay, we got that. All right, I feel like we're feeling good. I feel like I'm feeling good about this one. All right. Let me show you some disgusting code. Why is this code disgusting? Why is this? Ugh. I can't keep down my evil elixir here. That's my Code Wars code. Exposed. Oh, that's the indifferent just exposed me. My brackets have different spaces. That's the lovely slides.com. All right, let's think about this. So in this case, I'm going to check to see. So I'm looping through all my objects. I'm looping through my dog. I'm looping through Simba. Then I'm looping through Mashi. Then I'm looping through Salem. So A is going to hold each of my objects. I'm going to check to see if the object. Thank you for coming and doing that here. Thank you, buddy. I'm going to check to see if the object is a dog. And if it's a dog, then I'll bark. But if it's a cat, then I'll meow. What's gross about this? What don't I like about this? What if it's not a dog or a cat? It's a lot of added complexity. What if it's not a dog or a cat? What if I want to start adding all the different animals on my farm? So now, if I wanted to keep adding animals to my farm, not only do I need to add new classes for the like cow and chickens, but what do I have to remember and come back and do? After I add my cow and chicken class, what do I have to remember to do? I got to remember to come back and fix this random for loop. That makes no sense. This is not maintainable code. If you need conditionals and switch cases to handle this stuff, it's just not good code. You're going to forget. Your code's going to break as you add more stuff. So what if there was a way, all right, provides a way to perform a single action in different forms, right? Like what we saw previously enables us to perform a single action in different forms. It provides an ability to call the same method on different objects, right? So we don't have to, our code we saw before didn't have to have some conditional logic that we maintained. It's too complicated. It's not abstracted. It's going to break. It's not maintainable. It's not encapsulated well enough, right? It doesn't have any of the things that we've learned about so far. And so instead of conditionals and switch cases and all of that ugly code, what we actually saw here is something very special. What we saw here was very, very special bit of code. What we saw here with that speak just working, we were able to have a single action just saying speak that worked on all these different forms, and we were able to provide an ability to call the same method. We were able to call speak on all of these different objects. We were able to call speak on cat. We were able to call speak on dogs, and they did different stuff each time. We didn't have to maintain all these conditionals. Didn't have to maintain all these switch cases, all this stuff that would make our code gross and disgusting because it's not well encapsulated. It's not well abstracted. It's not, it just makes it too hard to maintain. We're going to lose a lot of sleep at night if we have to maintain all those conditionals and switch cases. And so, my friends, what we just learned polymorphism, baby. That's polymorphism. That's what it is. Hey, let's go. Why is polymorphism easier than conditionals? Because you have to maintain those conditionals. You have to maintain those conditionals, right? Here, do I have to maintain anything? Do I have to maintain anything here? Wolfpack, thank you for the hydration. Cheers to you. As I add more classes, as I add cows, as I add chickens, as I add all these as I add all these new types of animals, does this code have to ever change? No, it just works, baby. It just works. Polymorphism. Oh, sorry. I didn't give the warning. I apologize. I'm always going to try and give a warning. I got too excited. All right. I don't have to maintain this. All right. Don't have to maintain this. Everything we were talking about object oriented is coming up with a system that makes our code more maintainable, easier to understand, and make sure we don't lose sleep at night. If we're using polymorphism, we know that we don't have to maintain some really rigid conditionals or really rigid switch cases. It'll just work. There it is, folks. Polymorphism in play. All right. Let's run it back. The 4 pillars, if they actually made sense. Encapsulation. The process of storing your functions with the associated data. So putting your data and functionality together, fusing them into one thing that is an object is called encapsulation. But why? Why does encapsulation matter? Well, it makes it easier to add new stuff. You're not running through your whole code base to find out where to add stuff related to cats or dogs. It's neatly encapsulated in that class. It makes it easier to read through what was already coded. If I want to go and I want to change something about a cow, I'm not looking anywhere else except for the cow class. It made it so that we're not afraid to make changes. If I make a change somewhere, it's not going to break my code elsewhere. Right? It's not going to break my code elsewhere. Why didn't they just say all this in the first place? Abstraction. It's just about hiding details and showing essentials. But why? Why does abstraction matter? It makes our code smaller and more manageable. We're able to break apart the complexity and not worry about it as we're working on other bits of our code. When I sit in that car and I start turning the steering wheel, I don't care about how the engine works. I just want to be able to drive, right? Same thing with our code. When I'm working on one portion of my code, I don't have to be worried about how all the rest of my code is working. And a lot of times I want to expose just the things I need so I don't step on my own foot or step on the foot of my other developers. So we kind of saw some of that like private stuff that we'll get into deeper later on. But that was also a form of abstraction where we're saying, look, I only want to expose the things that matter so I don't mess up everything else that's in my code base. It makes your code changes. It makes sure you can make your code changes and still sleep at night. When things are well abstracted, you're not worried about when you add new stuff that it breaks other things. If your code is well abstracted, you don't have to ever worry about that. Inheritance. You make a class from another class so that you have a hierarchy of classes that share a set of properties and methods. I'm not proud of this one, but I like it. And so what else it is just that we have these classes that can inherit properties and methods from their parent. So we're making children, and those children can inherit properties and methods from their parents. But why? Why is inheritance important? It helps you eliminate redundant code. If you have really well-defined parent classes, the children get all the goodies from the parent, and you don't have to keep repeating yourself over and over again. We started to see, right? We started to see that, all right, well, maybe we were repeating breed. We were repeating these things. Maybe that should have went on the parent class, all right? Polymorphism. Code written to use an interface, right? So we wrote that for loop that was using the speak method, knows how to work on any number of different objects. So that speak method is going to work on a cat or a dog. It doesn't matter. It's just going to work. which saves us. It saves us from having to do silly if else's or switch cases or conditionals, or really importantly, our code just works. Our code just works. We don't have to worry about maintaining different pieces of our code. We don't have to worry that we add more classes as we add chickens or cows that our code will break. It's just going to work. So this makes your code more reusable, right? It makes your code more reusable, and it supports the other pillars. This polymorphism is kind of like, it's very much entwined with inheritance, but it helps support the other pillars so that as we're encapsulating and abstracting, we can expose things that just work as our code base gets more and more object oriented. How we feeling? How we feeling? Lit dab, lit dab fan slider. Thank you for the sub. Thank you for being here. Brain equals fried. Smarter. A lot of info tonight. Yeah, we kind of jammed it in here. We're going to have a lot of fun on Thursday, so I had to get some of the heavy hitters out tonight. Good, smiling through the tears. That was awesome. My brain is shut down. Sleepy time. Nora's need to suck this up. Exactly. Got to rewatch. I hope you do. Hope you do. Good stuff. Brain hurt. Cool. Polymorph my brain. All right, folks. We didn't get a chance to do the kind of the going over to Remo, so we're not going to worry about that tonight. I want you all to let this stuff marinate. Let this stuff marinate. Rewatch the pieces that are tricky to you. If you really get encapsulation and abstraction, great. If you really get encapsulation and abstraction, wonderful. Spend some time reviewing the harder things for you. Go back and look at inheritance. Rewatch the bit on polymorphism. Play with the code. Please take the code, right? Please take the code, play with it, break it, add new classes, try using super, try not using super. This is your homework. I want you to play with all this stuff before Thursday. It's really important that you play with all this stuff before Thursday. Yeah, we're not going to go over to Remo because we're already at our 3 hours, right? Please play with this. Don't have sat here and then don't play with this either tonight, tomorrow, before Thursday's class. It's really important for these concepts to actually stick and to for them to sink in, for you to literally play with the code and be like, oh, what was that loop really doing? Why am I doing this? What is the reason? Really make sure before Thursday, what you want to have a good idea of is like, all right, you want to be able to yourself say what encapsulation, what abstraction, what inheritance, and what polymorphism is. You want to be able to say that in like very clear, plain language that makes sense to you. If you can't say out loud what those 4 things are and what they mean to you, then you have to come back and rewatch this. And then once you're able to explain what it is in plain language, you want to be able to say like, why? Why is it important that we have these 4 pillars of object-oriented programming, right? It's not important to just know the definition. The definition doesn't help us at all. We're all reading the definitions. It did nothing to help us, all right? We have to know why. What was the reason? So work through the pillars, break the code, right? Break the code, right? Break the code. Diabolical is going to be streaming before our class on Thursday going over this stuff. Definitely make sure you check out their stream if you're having trouble with this and you want to tackle it from another perspective, right? And then come back on Thursday and we're going to review it. We're going to make it make sense. We're going to see more examples. We're going to play with more code. But I need you to put in the effort between now and next class. I need you to put in the effort. I just need you to play with it, to try and grapple the topics and come with questions. Come with questions on Thursday that we can work through And boy, do we have a lot of surprises on Thursday. We got a lot of stuff that we're doing. We're doing the VIPing from the Code Wars. We are raffling the Pokemon cards. We're showing, I already have all of the envelopes signed, stamped. I just got to put the card in them and drop them in the mail. Those are all going out. And then we're revealing some really big news about 100 Devs, the future of what the program could be. And so come back on Thursday. We're going to make some more of this stuff make sense. And we're starting to gear up for the back end, folks. We're shifting gears. We're going to go into a whole new thing, and we're shifting gears. Alrighty, folks. Let's go ahead and do a raid. And then please take some time after the raid to work through this wonderful, wonderful stuff. All right. Going to go ahead and set up the raid now. Don't leave. Stay for the raid. Get the channel points. You want them. You need them. All right. Let's go ahead. Setting up the raid. We're going over. Alrighty. I hope this was helpful. Hope you learned a lot. We are raiding in 6 seconds. Let's go over. Let's send them some love. Give them some positivity. Lots of follows. I'll see you over there, folks. Peace. Take care. Have a wonderful night.